Hey everybody, welcome to Authenticate 2020. My name is Pam Dingle and we get to talk about profiles, pins, and protections, oh my, which might be the longest title of a session that I have ever given in my entire life. I am the Director of Identity Standards at Microsoft, which means that my team has been working for a long time in the FIDO Alliance on the topic of FIDO2, on trying to get WebAuthn working in W3C and in lots of other different ways. So the goal here is pretty simple, and that's to talk about magic. So when you look at the things around you, they might be beautiful and functional, and you may or may not have to understand what's behind the beauty and the functionality. Some people do want to know and some people don't, and that's really what we want to talk about today. FIDO is a magical thing. We have worked very hard to create two worlds, a world where you can simply plug in a security key and use it, or where you can, open up your laptop and have the biometrics built into your laptop simply work to speak on your behalf as you authenticate to websites. And we think that beauty is amazing, and it's very, very important that the usability promise stays intact. But not everyone can consider the technology magic. And so this session is for those of you who want to take the next step behind the magic to kind of understand how the specification works and what the concepts are that actually underlie this technology, why it's safe. So this presentation is for you, those dissectors of magic. So let's talk about my daily magic. What I do every single day. When I use my FIDO authenticator, I use my FIDO authenticator on a Macintosh, a Mac Mini to be specific, and I use a security key. So the thing about a Mac Mini is it's headless. It doesn't have facial recognition. It doesn't have a fingerprint reader. And so I have managed to add one in a standards-based way by plugging in my security key, which is pretty great. And every day I go through the same very simple ritual, which is to place my finger on the security key that you can see in the picture here. And that by itself allows me to get access to my websites, which is super cool. However, there is a lot of detail behind what that means for those of us who really care. And so, the reason why I have chosen this particular set of capabilities are that I didn't want to type. And that's not always the same thing that people care about in the FIDO world. Some people are happy to type. They just want a little bit of security afterwards. In my case, I don't want to type my username. I don't want to type my password. I just want to, touch a thing and go. So that was the important restriction for me in trying to design, my interface with my web servers. So I'm now going to show you the different ways that ritual occurs, and we'll just talk through some of the concepts behind how that happens, so that, not enough so that you can be an expert, but enough so that you can go back into the specifications if you want to and look them up. Right, so here we go. We're going to do two things. We're going to talk about how I get to GitHub, and we're going to talk about how I get to Azure Active Directory, which I know you will all be shocked to hear that I, as an employee of Microsoft, I spend most of my day using Microsoft tools. Okay, so let's get started with GitHub. In the case of GitHub, you do have to enter a username and password. And so the first thing I need to do is enter my username, my password. In this case, this is not actually my production GitHub account, just for privacy reasons. So after I submit my username and password, I have to tell the system what happens next. In this case, I do want to use a security key. I could opt out and go to some other factor of authentication. If, for example, I was in a different location and I couldn't use that USB security key, or maybe I cut my finger and therefore the fingerprint reader would not work. So I'm going to select security key here. And now you can see I'm being challenged to actually touch my security key. So super easy. I am going to go, and in fact, in this case, I am going to touch my security key, not with my finger, which has my biometric enabled, but with my knuckle. So like this, I'm going to touch that security key, and then I'm going to be let in. And that's the reason why I'm saying this is because that is part of the magic that is behind this interaction. So just as a quick recap, username, password, touch my security key with the knuckle of my hand, and I'm in. That's the flow we're looking at. So let's pull that apart. What just happened? So first off, we can talk about initiation and discovery. In this case, we saw that we had a regular 2-input login form. So it's worth calling out this was not an identifier first flow. They did not ask first for my username and then choose the mechanism to challenge for. They combined the username and the password together into a single thing. And that's significant, as you'll see a little bit later. Now, we had a 2-factor flow. The first factor was, of course, the password, something I know. And the second factor was something I have. And it's important to understand why the thing you just saw is something I have. And that the reason why is that I performed what's called a user gesture. So in reaching out and touching that sensor on the security key, I proved that I was proximate to the key. And by proving that I was proximate to the key, I can prove possession of the key, right? So this is sort of the important language here. And the way that this happened was by using a user presence test. Now, a user presence test is different from a user verification test. In a user presence test, any human being around can pass the test. And that is why I was able to touch the key with my knuckle rather than having to touch the key with my finger. Any kind of touch is enough to prove that presence, right? So we ended up with 2 factors. We ended up with the FIDO authenticator in a 2nd factor role. Let's talk about what other things happened here. We saw that we had a WebAuthn interaction, meaning that we used a protocol called W3C WebAuthn. And what W3C WebAuthn does is it codifies a JavaScript API that can be offered by a browser. So I used a FIDO-enabled browser. In this case, I used Google Chrome as the browser to make a request from the GitHub relying party all the way through to my security key on my machine. And this is pretty great. So that WebAuthn API can work in one of 2 ways. It can integrate with a CTAP1 device, or it can integrate with a CTAP2 device. This one was a CTAP1 device. Now, the cool thing about the CTAP1 devices is that CTAP1 really came from U2F, and U2F is an older, very cool specification. What U2F used to contain was a JavaScript API and an assertion format, those 2 things together. WebAuthn has superseded the JavaScript API piece, the request and response mechanism, but the assertion format remains. And so in this case, we are using a U2F assertion format with the WebAuthn request response via browser API, and boom, it worked. It's pretty great. So next thing down is the attachment modality. So how was it attached? It was a cross-platform attachment modality. And what that means is that the authenticator is roaming. It means that I can pull that security key out of the machine and walk away with it. I can plug it into my Windows PC and still be able to use the same fingerprint sensor to get to GitHub. Very, very important, right? The opposite of a roaming authenticator is a platform authenticator. And the platform authenticators are generally biometrics or other mechanisms that are part or built in to the computer itself. So there's nothing you can pull out, move. It's part and parcel of the computer that you are using to access your web resource. And then most important, and the piece we're going to dig into next, is that this was what we call server-side key storage. Now, you may have also heard of this as a non-resident key. This is one of the things that in the next version of the specification, they have tuned the language for, and we're going to dig into that next. So let's look at server-side key credentials. what you can see here is a managing authenticator, and you can see a relying party. So I've only really, narrowed it all down to that specific paradigm. GitHub is the relying party. So GitHub is relying on the authenticator in order to validate an account and know that the person who's attempting to authenticate to a given account really does deserve to be let into that account. So you've got your relying party, you've got your managing authenticator, and what goes back and forth is of course mediated by the platform. It is mediated by the browser, and it is mediated by, in some cases, the operating system. But we're going to skip all that because in some sense, they are just tunnels and security supervisors to the process. So what you see here is what happens in a server-side public key credential flow. You will see that the relying party will have stored a credential ID, a public key, and some authenticator information about where the authenticator came from, who the manufacturer is, a few interesting things like that. Now, the credential ID is the unique identifier that matters for a WebAuthn request. When you make what they call a challenge, so you have to construct a challenge that gets sent to the managing authenticator, and you can specify various options for what you care about when you make this challenge. But the primary thing that you have to have in the challenge when you make a request for a server-side public key credential is the credential ID. It is not possible for the managing authenticator to satisfy your request unless you already send your credential ID inside of the request to the managing authenticator. And the reason why that is the case is because the private key that is in fact associated to this origin, to github.com, is not stored on the managing authenticator. What is stored on the managing authenticator is what we would call an attestation key. And attestation keys are complicated and they can come from multiple sources. They may be paired to a certificate authority in the cloud. They may not be paired to that certificate authority in the cloud. They may be self-generated. But the attestation key is the thing that never leaves the device. The actual credential, in this case, the server-side public key credential, does leave the device, but it leaves the device in an authenticated format that is useless to anyone without the original seed. And the seed is securely stored in the managing authenticator. So you can see that there's a dependency here between the private key that does get sent in encrypted form to the relying party and the managing authenticator. And the whole goal of this is that the credential ID contains the private key, the relying party ID, and all the information that's necessary for the managing authenticator to act. But it allows the managing authenticator to operate statelessly. So you don't have to have in your managing authenticator a whole bunch of super secure memory. And so that makes the managing authenticator cheaper to produce. And it works better in some scenarios. So here we go. We've got the challenge coming in with the credential ID. It is imported into the managing authenticator as part of the request, and then the user must perform their gesture. What happens is that the user gesture is what unlocks the ability for the attestation key to be used to unlock the private key for the credential and then create an attestation that can then be sent on in order to validate the user's activity and the user's identity, or at least their handle. It's not really their identity. So we have an unlock from a user gesture of the private key that then decodes the credential ID in order to find out what the private key is for this particular credential. And then you have a signed assertion, right? Signed by the private key that just got decrypted because a user gesture was used to unlock the encryption key that was stored in the managing authenticator. And boom, the assertion comes back. The relying party can use the public key for the credential, not the public key for the attestation key. and they can validate, and Bob's your uncle, you have just logged in. So when I say that there's a lot of stuff behind the magic, I am not kidding. Right, so here's one other way to look at this. You can see that when I type my username and password, what I'm doing is I'm allowing the relying party to find the credential ID that is affiliated to my account. Once that credential ID is known, I can make my WebAuthn challenge with the credential ID. That gets sent to the authenticator. The authenticator can then ensure that the user gesture is successful. In this case, just a touch of the sensor. And when the touch of the sensor occurs, now the credential store can be unlocked. The attestation key can be used to decrypt what's in the credential ID. And the signed assertion will go back to the relying party to basically say, here's my assertion that this key, that you can validate to ensure that this key was used properly. So that is the whole round trip, and that is a server-side key round trip. All right, so that's half of it. We are halfway there. The next way through our magical journey is to look at Azure Active Directory. So Azure Active Directory is a WebAuthn relying party, and it has a different set of requirements for how the FIDO flow can work. What you can see here is we have an option of sign-in options at the bottom of my daily Microsoft login form. So this sign-in options, when I click it, you can see that one of my sign-in options is to sign in with a security key. Now, if I was on a PC, I could use Windows Hello, and that would work just fine. In this case, of course, we really only can use a security key. All right, so once I choose that sign in with a security key option, you can see the same challenge. So this is actually a Microsoft Edge browser rather than a Chrome browser, but you can see that the challenge looks the same because they both are using the Chromium backend. And they are challenging me to use my security key, and they're telling me that it's login.microsoft.com. So the web origin that the credential will be bound to is login.microsoft.com. All right, and I am going to touch this security key. Now, if I touch this security key with my knuckle again, it will fail. I will not be allowed to continue. In this case, I have to be able to touch my finger with my fingerprint that I had previously registered with this authenticator to continue. All right, and the reason for that, we'll talk about it in a minute. So I'm going to do that. I'm going to place now my specific finger on the fingerprint reader, and it will be recognized, and one more thing will happen. Now, this one thing is a selector. A selector has come up. It turns out that in the case of Azure AD, I have stored multiple credentials on the same authenticator, all of whom have who have linked accounts within Azure Active Directory. So you can see here, I have a corporate credential, I have a consumer credential, I have a demo credential, which is great because I don't have to remember passwords or share passwords for my demos. And I also have actually I have 2 demo credentials. So all of those are stored, and with one click, I can just choose which one I want. I, of course, just want my corporate credential in this case. And by the way, if I don't want to see this step, I can just simply use different authenticators per credential. I can do that if I want to. I find this more convenient. I use these other credentials often enough that it's worth it. Same thing, an easy flow, right? I clicked a couple of things, I put my finger on the sensor, and I was allowed in. I never had to type anything in this case. I did not type my username. And because I did not type my username, this means that that my credential was discoverable, right? So if you think about the last flow, you can see that the username and password could not be discovered. You had to be able to have the username typed in first. You had to have had the relying party understand what account the user was trying to access before they made the WebAuthn request. In this case, we were able to make the WebAuthn request blindly, and we were served back a set of possibilities as to which actual account the user was trying to use to log in. So that's kind of cool, right? This is why I didn't have to type. This is why my WebAuthn credential was able to say, hey, this is Pamela Dingle with this corporate account. And by the way, she's cool. You should log her in. So this concept of a discoverable credential is a really big deal, but it has downstream architectural requirements affiliated with it. So let's go through the rest of the list. Factor one was, in this case, not a password. Factor one in this case was user presence, right? I performed a user gesture on, over USB transport in a way that was provable, right? And so I can provably say that I was in possession of that particular security key. Now, the second piece was the actual touch of a recognized finger to a fingerprint reader. So in this case, I have something I have, which is possession of the key, and I have something I am, which is my fingerprint. Now, keep in mind, the fingerprint does not leave the device in this case. So, there is no centralized biometric flying through cyberspace. But what has happened is essentially two different types of user gestures here. Presence was tested through a touch, but individual unique identification also occurred through the biometric collection. And so that's pretty great. One touch gets me a twofer. It gets me something I have and something I am. Right, and so the next thing to notice is that WebAuthn is still in use here. The beauty of WebAuthn is that it can cover both discoverable credentials that are stored on the client, discoverable credentials and non-discoverable credentials, also client-side and server-side credentials. So what you saw earlier was server-side. What you're going to see now is client-side. And so WebAuthn allows you to ask for both. That makes it much, much easier for a relying party. They don't have to know the difference. They just need to ask for the things that they care about. And you can see that CTAP2 is in fact the client to authenticator protocol. So before it was CTAP1, now it's CTAP2. It is CTAP2 that allows this discovery to occur in a way that doesn't require any typing. There are other ways to do discovery, and we'll talk about that in a minute. All right, and then we still have the cross-platform attachment modality. This is still a roaming authenticator. I could still unplug it and walk to a new machine. But now we're going to talk about the key storage. Where is the credential key stored? It is the credential key in this case is resident on the managing authenticator, right? And that makes it a discoverable credential. Of course, the cryptographic seed that pins all this does not leave the device. That's sort of a given. And then there are three additional things that are going on here. In our case, the Azure Active Directory relying party requires that a client pin also be set on the device. There was no client pin in the last demo. There was no client pin in this demo. But the difference was if I had cut my finger or if I couldn't use my biometric, then I could have on the same key used a pin instead to authenticate. So it basically gives you backup right on the authenticator instead of having to step back to a different mechanism that the relying party offers. All right, so that's resident key. Client pin, we do have the ability to, in theory, do device unlock with a security key in the case of it being a discoverable credential. We're not even going to talk about that's advanced. We're not even going to talk about that. But the last piece is the multiple account support. So multiple account support was the selector that you saw and the ability to store multiple discoverable credentials all on the same authenticator, all for the same relying party. It's a very cool feature. Okay, so let's talk about client-side public keys now. We talked about server-side before. This is client-side. There's a big difference. But the big difference is only on the authenticator. It is not on the relying party side. Again, this is the beauty of WebAuthn. It can abstract away a lot of this detail. So on the relying party side, what you can see is that you have a public key, you have a credential ID, and you have authenticator info, identically to what you would have had in the server-side key scenario. The difference is that the credential ID that you can see in a client-side public key scenario really is an ID. It is an identifier. It is not, a mystery wrapped in an enigma like it is with the server-side key. It is simply an identifier. It is used as a primary key to do a lookup. And so again, we have the challenge, a WebAuthn challenge, the same way we did in the case of GitHub. We have the server-side challenge, we have a WebAuthn challenge. That challenge goes across to the managing authenticator. And here's the difference. In the case of a client-side public key, the private key that matches your public key is stored on the managing authenticator. It is, stored in the credential storage right alongside the attestation key. So it's not that the attestation key goes away. It's just that it's stored in the same location instead of a different location. Again, this credential store requires a user gesture for unlock. And in this case, our relying party has put a higher bar on what can be done to unlock the credential store. They have asked for user verification instead of just mere user presence. And so, you don't have to do that with a discoverable key. It's just, a best practice, if you will. So the challenge comes in, the user gesture, whatever you choose, is performed, and the credential store is now unlocked. The credential store contains the private key. So the private key is now looked up based on the identifier, and an assertion is created and sent back. Now, how does this work with multiple relying parties per account? Well, what happens is you can choose to send a specific credential ID in order to get an assertion back for that credential ID, or you can leave that, what they call the allow credentials list, empty. If you do that, then what happens is the managing authenticator will look up all of the credentials that are valid for that specific web origin, and you will have an option, right? You will be given an option that the relying party never sees. So this is very important. When you saw that list of credentials was fielded in this case by the browser, and it existed before any kind of assertion was sent to the relying party. So the relying party could not see that I had 4 different accounts that could be chosen. Only the browser could see that. And the browser is your trusted, trustee assistant in this matter. And so there's actually a little bit of extra hop here where the browser can display, just enough credential information for each of the possible credential IDs that could be used to create an assertion. It's going to display it to the user. The user is going to check it, and then the assertion gets sent to the relying party. So, it's a little bit of extra awesomeness, a little bit of extra magic, but it sure does allow for some very interesting outcomes. And of course, the rest of it is very much the same. You still have the public key that was originally sent to the relying party at the time when the credential was created. That public key is going to be used to validate the assertion that has come back from the managing authenticator. And if the validation works, then the user is going to be allowed into their resource. Okay, so that was a lot of talking, a lot of pointing at diagrams, but there's some pretty great outcomes that come from this kind of magic. So first of all, it allows you to make choices as a relying party. So if you are, an administrator who's looking at setting up a relying party, then you really do want to look into what these options are and why they matter. And they mostly matter because it changes how the user experience can flow. Now, one of the things that we did not see in this presentation that you probably want to go look up is something called an identifier first flow. Now, had I typed in my email address into the original flow that you saw for Azure AD, instead of clicking the sign in option at the bottom, then what would have happened in that case is that Azure Active Directory would have looked up all of the possible authentication mechanisms for me and given me a choice of which one I would like to use to validate my account. In that case, had I typed that flow, the user, I could have in fact chosen an authenticator that either was using a server-side key or a client-side key, because now we know the user that it's applicable to, right? So you need to be sure that just because your authenticator is a server-side key, it doesn't mean that it can't be the first factor in authentication. So you need to keep that in mind. Second of all, you need to decide whether you want to ask for user presence or user verification. In this case, you know, I talked before about what the conventions are. The conventions are, if you're going to use a FIDO authenticator as a first factor, you better use user verification and not just user presence. The last thing you want is for somebody to use their knuckle to log into your key in order to get to your resources. So that whole question of whether you use user presence or user verification is very much tied to how you decide to initiate and whether you use a discoverable credential. In the case of an identifier first flow, you can use either server-side or client-side keys, but in the case where you want to initiate only from a link, it has to come from a discoverable key or discoverable credential. All right, so those are some of the big pieces. What else do we need to talk about? We need to talk about the things that are inherent in any FIDO authentication, and that includes the ability to certify that a user gesture is always used. So we do not want these things firing off attestations that are not under the control of the human being, and also the ability for these authenticators to be certified. So it's, you know, we talk about secure credential storage as, you know, just an obvious thing, but it actually takes a ton of work behind the scenes for that credential store to prove that it's not, you know, it can't be attacked by timing attacks or side channel attacks. So there's a lot of additional far deeper magic that goes into these authenticators than even what I have talked about today. All right. This is just some of the magic, but I hope it's been useful. I would love to talk to you more in the chat. We're going to do a chat right after this presentation. And, you know, you can ask the deepest, craziest questions, and I may or may not have an answer. However, I hope this has at least given you an idea of the broad strokes of, you know, what lies just under the surface of a FIDO authentication and why you might need to care about it. You know, if you want some next steps or homework, there are some really great demo sites on the internet that play the part of relying party, but will show you, you know, what happens when you make these requests and what comes back. So I would suggest taking all of the terminology that I've covered in here, like attachment modality and, you know, credential store, and go to those sites, and you'll now hopefully be able to press those buttons and understand why you might want to differentiate between the different types of settings. So that's my suggestion for a next step. My name is Pamela Dingle, and I hope you had a great time.